Okay, so if you guys just came in, please again try to get connected to the network and then find a partner to work with. And then if you go to the ImageJ website and go to this presentation, there's a link. There's a link here, and click on this link to get an interactive version of the tutorial. We search for SimpleITK, and then scroll down this link right here. If you click there, you should get to the tutorial. And we'll get started so we don't go too late. I know it's getting kind of late, but this should be pretty fun, a little different. We're going to try to make it a little interactive. And if you click on that link, you should reach a page like this. And this page, we are going to start off, you click these notebook files, and then we'll start off with this one, the index. And if you're having trouble, try Firefox or Chrome. This is where it should work best. And so, are we ready to get started? Okay. So I'll get started. So this is the image registration with SimpleITK tutorial. And we're going to be going over this material. Again, here's a shortened link, but if you go to the ImageJ conference website, to the wiki, this link is there, bit.ly, 1H, capital D, 5, F, Z, F. And so my name's Matt McCormick. I'm coming to you from Kitware. And in this tutorial, we're going to be going over SimpleITK, which is a very nice tool, part of a toolkit. We're going to be going over registration and how to do registration within the SimpleITK framework for image registration. So one way or another, we should talk a lot about kind of image analysis and processing, especially in registration. And the goal is to learn things and active learning. So hopefully you come away with something that's useful to you, either programming, computing, image analysis, and image processing. And so the outline of the session is we're going to first do an introduction to ITK. It might not be familiar to a lot of people here. We'll talk about what that is in SimpleITK and how it's related, and then also how that works with Fiji/ImageJ. And then we're going to be doing a set of exercises, and we'll start off with a little overview of the material, and then it'll be you and your partner working together, and you'll go through some of the material yourself, and then there's some exercises at the end, and then we'll review the exercises. So please, again, get your laptop out and find a partner if you haven't already. And the type of topics we're going to be covering today are images and physical space, and we'll learn a little bit about good practices for working with images and doing operations in physical space. Then we'll go over the process of resampling images and how that works. And then we'll go into a little bit about spatial transformations, which is important for registration. And then finally, we'll talk about similarity metrics and optimization. So these are all kind of the components and the processes that go into image registration. And again, image registration is when you have two images, either similar things in the images or the same content taken at different time points, And you want to find the spatial transformation that lines them up so that they're aligned again. And that's kind of what registration is. And that's a problem that comes up all the time when we're trying to get useful information out of our images. So the next thing to start with is the introduction to the Insight Toolkit. And I thought I'd introduce myself a little bit since we're going to be working together for a little bit. And again, my name is Matt McCormick. I'm actually alumni here. I don't live or work here anymore, but I grew up in the Midwest, and I love ice cream, as shown in this picture. I have good taste, which is ice cream taste. I'm very experienced in that, and I have my nice Madison t-shirt from the marathon. But I graduated here in 2011. The area I worked on was medical imaging and ultrasound imaging, and that's what I did my thesis work on. And after I finished doing medical imaging, I worked at a company called Kitware. That's where I still work. And we are an open source software services company. We do consulting and collaborative work with people in academia and in industry. And I've been doing a lot of work on this project, the Insight Toolkit, that we're going to be talking about, ITK. And the Insight Toolkit is for image analysis, but there's a lot of other projects that we work on at Kitware, including tasks such as computer vision, working with quote-unquote big data. I do mostly medical computing, but there's also kind of the HPC and visualization. If you've heard of the visualization toolkit, VTK, or a GUI called ParaView, that work comes out of these folks at Kitware. And then we do a lot of work kind of in scientific software engineering and software process, so making good software through open source practices that works really well, tooling there. An example, a recent thing that we have going on, is a project called TomVis. And TomVis is for tomographical visualization. And so we're working with some people at Cornell who they do atomic microscopy, TM microscopy, and they want to work with us, the visualization guys, to do very good 3D visualization. And now they're also bringing in ITK, the Insight Toolkit, to do some segmentation and analysis of their images. So this is the type of work we do. But I came into a little late of this very large project, kind of like ImageJ Fiji, the Insight Toolkit, that was also has origins and connections with the NIH, National Institutes of Health, and also the National Library of Medicine. And so it started with a project that you can kind of think of as something like the Human Genome Project, but for medical imaging. And they called this the Visible Human Project, where they went and they wanted to do a high-resolution 3D image of a full person. They took people just after they passed away, 2 people, a man and a woman, and they imaged them with all different imaging modalities. So that started back in 1999, and it's continued since then. And the goals of the projects was to collect best of the best image analysis algorithms for reproducible science, provide software for leading medical imaging algorithms, establish a foundation for future research, support commercial applications, create conventions for future work, and grow a self-sustaining community of software users and developers. And so work has continued since then. There's been contributions from many hundreds of developers. There's 1 to 2 million lines of code, and is downloaded many times. This is a visualization, a graph of all the people who did code reviews, who did a code review to the other person, and how many commits they did over a couple of years. So it's a big community. And more recently, in 2011, there was an effort to create a simplified interface, programming interface, to the Insight Toolkit, and that is called SimpleITK, and it builds on top of ITK as a different interface for it. And it's intended to facilitate its use in rapid prototyping, education, and interpreted languages. So the first release was in 2011, or one of the first releases. And so it also comes with binary distributions for Python and Java. So it's a good option if you want to do image analysis. And today we're going to be using the Python interface. And hopefully you find that even if you don't consider yourself a programmer, this is accessible and a useful tool and available to you, and you're capable of using it. So the features of this toolkit is kind of like the ImageJ2 approach, so for scientific images, not just your snapshot photos, so n-dimensional image filtering, and it's targeted some of these more difficult algorithms, traditional algorithms, segmentation, here where you're trying to identify objects in an image, and registration, which is what we're going to be focusing on today, and that's where you have multiple images and you need to find the spatial transformation again between them that aligns them in some way. They can be the same modality, a different modality. But it's also extended, it has support for other things other than images too, like meshes, transformations, paths. So people who are doing analysis of dendrites from neural cells. And here's an example of a mesh, and here's an example of a visualization of a transformation, again, in space. So what is really interesting, how does it work with ImageJ and Fiji? So there is a module for ITK that was developed a couple of years ago that uses Scipio. And this was developed by Mark Heiner and Curtis Rudin, and they deserve most of the credit for this. This is really an excellent thing to have. So the ITK has a support for many different imaging formats, but this really brought in better support for a lot of the microscopy formats. And again, really big credit to the guys at LOCI. If you get a chance to support them, I highly encourage it. And I think Curtis mentioned today in passing that someone you should consider on your next grant hiring a programmer to help with your work and then also to help contribute to the maintenance of ImageJ and Fiji. And I think that's a really good idea, and please consider doing that. I think people should take that seriously. And do as much as you can to support the great community-driven development that's happening here. So if you want to use Scipio in ITK to read in images, when you're building ITK, you have to set an option on build time, and you just turn on an option called module Scipio, and then you'll be able to read images through Scipio in ITK. If you want to go a different route and try to export images from Fiji into a format that has really good native support in ITK for n-dimensional images and the metadata surrounding the images, a good format to choose is meta-image, and Fiji comes with a plugin to help you export that. So you'll go to File, Save As, and then you want to choose one of these MHD or MHA file formats, and that works 2D and 3D. And that will work very well with anything that's based on ITK or BTK. And another relationship to be aware of is that SimpleITK, if you're using it on your desktop, it won't work in this web browser, but it will use ImageJ or Fiji by default to show images. So it's ITK and SimpleITK mostly for analysis, but in SimpleITK there's one simple method that's available, show, and what that does is actually just goes and will open up ImageJ by default. And it looks like we're now migrating to Fiji, so in future releases it may be using Fiji by default. So enough of me talking. The next topic we're going to cover are these Jupyter notebooks. And so this is where you get to get your hands a little dirty. Again, here's the URL. So these are interactive web-based platforms for having text, a narrative that tells a story, and you can have equations. But it also has code in line, and then the results, the visualizations of the code. So it's great for if you're doing an experiment and analysis, or if you're trying to teach some material. Oh, sorry. Sorry. Thank you. Back to this now. So this is a really great. It's evolved. It used to be just in Python, and now the new project has supports for lots of languages. If you're a very good Java developer, I have a request for you, is to write a plugin so that you can write Java in Jupyter. It should definitely be possible. There's dozens of languages implemented. But today we're going to be using Python. So how many people have been able to go to the URL and get started? Okay. Or how many people have not? This URL right here. Yes. Have you been able to go to that URL and start up the page? Yes?
No.
Yes? Anybody have trouble? No. Okay. So I'll just go through a brief overview of what to do next. I'll let you guys get started, but then I'll help anybody who's having difficulty. Again, find someone to work with if you haven't already. This is IPython, so kind of the next generation of IPython that works with multiple languages. But we'll be using Python today, yeah, if you're familiar with that. And so you just need to know a few things to get by today, even if you're not a programmer. The first is how to run the code in the cells. So you'll see text, and then you'll see code, like this one. And if you click on a cell, and then if you press Shift-Enter, and the cell is highlighted, it runs the cell. And below the cell, you see the output of what you executed. And a couple other really useful things to know is you can get help on functions or methods with the question mark operator. So you take a function like print, and put a question mark after it, and then press Shift-Enter. And a little pop-up will come up with the help for that command. Okay, and you can also use Tabcompletion to get a list of options. So you start typing a command, and then you press Tab. It will complete if there's only one option, or it will give you a list of available options if you press Tab twice quickly. So that's the basics of what you need to know to operate the code in the notebook. And another useful thing we want to do, since we're working with images a lot today, is how to display an image. And the library we'll be using is matplotlib. And this is a Python package, but it is very similar in its syntax to MATLAB. So if you've done MATLAB, you can do this too. It'll be very familiar. And you have to first make it available in the environment. So every time we start a notebook, we have to run these two statements that imports it and makes it available to display the images inline in the web page. And then next, we'll import SimpleITK just for this example. We'll be doing it more. Shift-Enter runs that. And you see when a cell is running, a star will be on the side. And when it's completed, it shows you the number that you're at in your run. And then this next example shows how to display an image. So we imported SimpleITK, and then we just call read image on this data, again, you can use tab completion on files that are available. So everything's in the data directory, data qdna.mha. And that'll return a SimpleITK image object. To display it with matplotlib, we have to convert it to the native Python numerical data type numpy. And we just call one function to do that, get the array, this is a numpy array, from the SimpleITK image. And then finally, just like the MATLAB command, imshow, we call imshow, and it will display the image. Okay, so that is the overview. Now there's a tutorial, and you can run through this on your own time. It should be helpful. Don't worry about getting through the whole thing, but just get what you can out of it. And at the end, there's a couple exercises, and you can move to those whenever you'd like to, and we'll come back to them and go through it at the end. Okay, so we'll go maybe 10 minutes and work on it.
Explain again how this could be related to image. Could you run the same thing with Java from a console?
It needs better Java support. I'm really surprised it doesn't have Java support. But the same API calls are the same. They're the same in Python as in Java. So you can use SimpleITK from Java too, if you want to program with SimpleITK.
The binaries available for Java?
The binaries are available. So if you go to the website, and then resources, download, and here are the binaries. They're hosted on the SourceForge. Sorry. Cool. Okay, so go ahead and please try the notebook. I know it's later in the day, but.